say this is the X, this is the Y, and out of the page, as if it's a dimension coming out of your screen toward you. This is the Z, okay? So X is this, Y is this, and Z is a dimension or axis along Z coming toward you, out of the page, positive Z, into the page, negative Z. So if I have this ball, I can say that this ball is in a space like this position. So it has a component. This component along X is this, because the ball is here. So what I will do projections. I will do projections. So this ball has a projection on the Y, and the projection on the Y is 2 units. The projection on the X, and the projection on the X is minus 3 units. It's along a negative X. It on the minus. Now I can utilize my unit vector notation to represent any particle in a space. Think of any, in your room, think of a certain point in space. Relative to you, if you consider yourself as an origin, you can define any point in space with 3 different coordinates, X, Y, and Z. So similarly, any point in space, and can define it as long as I know I hat, J hat, K hat, and I said how many relative to an origin along the X or negative X, how much or how many meters along the Y, and so on for the K. So now my position vector, which is a vector, is represented by 3 different vectors. Here to put an arrow from now on. Why? Because now we have a complete vector. Before, in 2 dimensions, we avoided putting the arrow in vector quantities like position and displacement, because we said we only have 2 directions, either positive X or negative X. So it's already represented. If it's positive X, then it's along the positive X. If it's negative X, and that's it. But in this situation, we have 3 different directions and possibly 6 different directions. So 3 different dimensions and 6 possible directions. Why? X, Y, Z, but I could have plus X minus X, or plus Y minus Y, or plus Z minus Z. Right. So now once we have a position vector, we learned something. We said the difference in the position between final and initial is another quantity that we learned. This is final and this is initial, and this quantity now you are familiar with. It is displacement. And notice that before we used to say what? Delta X, right? We used to say delta X. Why? Because only I have 1 dimension. We used to say it's X final minus X initial. And at that time, okay, if you put an arrow, it's okay, it doesn't hurt. But it's well known, it's a vector quantity. Now, if I have a final position in a space and I have initial position in a space, the difference between each dimension as a summation, as a vector summation, is what's called displacement. يعني الدلتا R, or the displacement now, is the final X minus initial X, طبعا I hat, final Y minus initial Y, J hat, final Z minus initial Z, K hat. Doing this, I can represent this quantity as what? Delta X. And I can represent this quantity, this scalar, طبعا. Remember, I told you what's next to the I hat, J hat is a scalar quantity. This is now delta Y. And I can represent this as what? A delta Z. So I can write my displacement in a more professional way, saying my displacement delta R is delta X I hat, delta Y J hat, and delta Z K hat. Now I can represent my displacement in 3 dimensions, which means the difference between those 2 points I decided to use as initial and final. The difference between them is the displacement between the 2 points. Right. Can we have more than 3 dimensions? Not in real world. In advanced physics, yes. And Albert Einstein considered the time as a 4th dimension, but that's a different topic. considered with very speedy particles, relativity. So we'll not discuss it here. In classical mechanics is where, by the way, I told you at the beginning of the course, classical mechanics is a science concerned with massive objects moving with a small velocity. Massive objects, remember all the examples we take in this class, 1 kilogram, 2 kilogram. So it's a massive object, and it's not moving with the speed of sound. It's moving at the speed of light or sound. It's moving with relatively small speed, 10 meters per second, 20 meters per second. A car, those are a small speed. So in this description of particles with their masses and their velocities, we consider these particles as a classical mechanics particles, which means in this case, I have only 3 dimensions, X, Y, and Z. But people who specialize in physics, they have up to 30 dimensions with string theory and other high energy physics, but that's not our topic. Okay, bye. So once we defined a displacement as delta r equals delta x plus delta y I hat plus delta y j hat plus delta z, define the only quantity we took, which is average velocity. Remember in chapter 2, what was the average velocity? It was delta x over delta t, and here is no different. The v average, of course, notice here the arrow. Yeah, it says a vector quantity. I need the arrow. Is now delta x, but delta x in 3 dimensions, it's delta r. It's the change in position between 2 locations. One is final and the other one is initial. R final minus R initial. Over delta t, طبعا delta t is a scalar quantity, has no dimension. So it's delta t, delta t. The clock is the same clock, whether in the x or the y and the z. The clock, which keeps the time, is ticking on all of them in the same way. So it has no dimension. Okay, so V average is now the delta x I hat, delta y j hat, delta z k hat, divided by delta t. So if you have a fraction like this, you can divide each parameter by the denominator. So which means delta x by delta t, now I have a quantity I hat, delta y by delta t, I have another quantity j hat, and delta z by delta t is another quantity. What is now this delta x by dt is V average along x. يعني x component of the, this is V average along y component, هذه y. And what is this last one? It is V average as z. So I have now broke down my V average into 3 components. يعني V average is a vector, is defined like any other vector. So when I say V average and there is an arrow on top of it, as if I'm saying I have V average x I hat plus V average y j hat plus V z k hat. So I can define it same way I define any vector. يعني, for example, a particle moves through the displacement, had a displacement, a 12 meter I hat, 3 meter k hat. So what happens to the j hat? It doesn't move along the j hat. So this motion is 2 dimensions. Which are these 2 dimensions? The x was z. So this particle only moving in this plane. Again, this particle defined in a displacement, a 12 I hat plus 3 meter k hat, means he's moving only in 2 dimensions. These 2 dimensions are the x and the z. So the particle is moving on this plane. على هذا المستوى فقط. He doesn't jump. The particle can only move along the x and the z. So he's only moving along on this plane. على صفحة, يعني if I take like this, so this is x, this is z, the particle can only, like an ant, an insect, can only crawl on this plane. It cannot jump. So this means that the particle is in 2 dimensions. Y equals 0, yes. We don't have 3 dimensions here. Here we have 2 dimensions. طيب, we'll go back to the example. A particle moves through the displacement, a 12 meter I hat and 3 meters k hat in 2 seconds. What is 2 seconds? It's the time required for the particle to move from an initial position to final position. He did not tell you the initial and final positions. He only gave you information about the total displacement. He only gave you information about the total displacement. And he told you the displacement is 12 meters I hat and 3 meters k hat. I don't need an initial final position in this case because I have what I need. I have the displacement. Now, if I want to find the V average, as if I'm saying delta R, change in displacement over change in time. What is the displacement then? 12 meters I hat plus 3 meters k hat, and the time is common between them. Remember, the clock is ticking for all the dimensions in the same way. Once I divide 12 meters I hat over 2 is 6 meters I hat, and 3 meters over 2, 1.5 meter. Now notice the unit. It's meter per second. Why? It is average velocity. And notice another thing. This here, between brackets, is what? Is V average along X. It's a component. It's a scalar quantity. And how about this? This one is V average along which dimension because of the k hat. Period. And I don't mind, you have coffee next to you, drink coffee, it's okay, it's fine. Have a cup of coffee, keep focus, okay? Israel is a good science and is a strong science and needs focusing, okay? Fine. Okay, good. Now, from here, we defined a new displacement in 2 or 3 dimensions possibly, not in 1 dimension as in chapter 2, and we extracted a V average. UV average, we can go and proceed and extract other quantities, right? So let's see. So remember, in chapter 2, we defined what's called V average, and we said we have another quantity, not average velocity, we have instantaneous velocity. And we said from the word in English, instantaneous means momentarily, بالعربي لحظيا, which means I need velocity at certain moment of time, not over a period. Well, what's the difference between average velocity and instantaneous velocity? Average velocity, you take in velocity over a period, 2 seconds, 3 seconds, 1 second, but it's a period. But if I ask you, what is the velocity of this particle now? Means give me the instantaneous velocity. So instantaneous before average velocity and the they have very interesting definition. V instantaneous before تذكر in 1 dimension, it was dx, the first derivative relative to time. And then what you do, you substitute, after you derive, you substitute the time. For example, I tell you, I want an instantaneous velocity at 1 second. After you derive, you substitute 1 second. Similarly, in 2 or 3 dimensions, in multi-dimensions, V instantaneous, not average now, it's called instantaneous, is dr by dt, which means the derivative of the displace of the position relative to time, the derivative of the certain position relative to time. يعني كيف position relative to time? If I have this here, x and y, notice here, I have x and y coordinates. And there is a particle here, this is the ball. So how you can define طيارات الجو القاعدة الجوية بالظهران. Okay. So if you have the ball and defined along x and y, okay? طيب. الآن, this position of the particle has x components along x and it has y position along the y. هذا only position, there is no displacement here, right? This is a position of this ball, the blue ball or greenish ball at the moment. This is a component along x and has component along y. Now, if I take a tangent, all of it is a position. Where is a tangent? A tangent. Let me just get a. pen. Okay. Change the color or مماس, right? هذا tangent. If I take a tangent at certain point of its position, This is the instantaneous velocity. Now, if I take, طبعا هذه velocity in 2 dimensions, so it has 2 components. If I analyze it into x component or y component, I get a v instantaneous x and I get a v instantaneous y from the components, because vector like this, you cannot use it. You have to analyze it into its both components, x and y. X and y. In the case of the displacement, ركز معايا. هنا you have the same situation but over a period, not instantaneously, which means I have this ball at position 1. Now the ball moved to position 2. What is this R1? Is the initial position. Now what is delta R? Delta R is this vector, but how to make sure that delta R is this direction, is not the opposite direction? What should I do? Use what? Use a summation of vectors. I will write the equation for you as if I'm saying it is R1. هذا summation of vectors graphically, right? Plus at delta R اللي هو what I want, displacement, should equal what? R2. You agree with me? واحد راح يقول يا كيف يعني؟ Yeah, I'm saying this vector plus this vector equal this vector. This is the equation I wrote. I can hear it too. Okay, good. Okay, thank you. طيب, so it looks like I add the vectors R1 plus delta R, and the summation of these two vectors is a vector called R2. طيب, and what you do, you just arrange, put delta R in one side, take R1 to the other side, what you get? R2 minus R1. And what is this? This is the definition of the displacement. Final means this is correct figure. This is correct graphical representation of the displacement. Okay, displacement, perfect. This is a correct representation graphically of a displacement. طيب. Now, once we have displacement, we defined average velocity, instantaneous velocity. In unit vector notation, instantaneous velocity is simply not only take the derivative of x, but also take the derivatives in 2 dimensions, 3 dimensions. What is this? dx by dt. And what is this? This is v instantaneous x. يعني the x component of the instantaneous velocity. And what is this? V instantaneous y. هذا V instantaneous y. And what is this? This is V instantaneous z. So each instantaneous velocity is defined according to its position. Ly will yield what? Vy. Z will yield Vz, and so on and so on. So V instantaneous can be written as Vx, instantaneous velocity along the x I hat, Vy j hat, and Vz k hat. And if you want to make it more clear, as if I'm saying Vx equals what? dx by dt. Well, Vy dy by dt, vector representation. I'll tell you what's the benefit. What if you said, give me the magnitude of instantaneous velocity? شو تعمل? V instantaneous magnitude. Instantaneous magnitude, only tell me how much is V instantaneous. And remember, we learned in chapter 2, instantaneous velocity magnitude is what? Instantaneous speed, same. Before, شوف علشان أذكرك. In chapter 2, we said, average velocity is totally different from average speed. We said average velocity is extracted from the displacement, while average speed, you don't need displacement. ما تعمل خطأ. إنه if he asks you about average speed, you try to get a common mistake. But if you have instantaneous velocity and you took the magnitude, immediately you can get correctly instantaneous speed. Correct, like chapter 2. Please, هذه عدتها كثير. Make this distinguish between or differentiation between the two things. Average velocity و average speed ما يقربوا بعض. They're not related. They're not cousins. average instantaneous velocity when instantaneous speed are brothers. If I take the magnitude of instantaneous velocity, I get instantaneous speed. So if I ask you, what is the magnitude of this V instantaneous? It is what? It is S instantaneous. أنا شلت which is equal to what? Square root of what? Vx square. Oh, this is the same way you take the magnitude. Vy square plus Vz also square. Instantaneous speed or magnitude of instantaneous velocity, square root, square. So I treat it as any other vector. Any other vector, I can find its magnitude by taking square root, square, square, square. Yes, remember, not just for velocity, Azizi. Any vector, components are scalar quantities. Any vector. يعني لو أكتب حتى الفورس فيكتور، هذا الفورس، شوف هذه حكتب فورس فيكتور in 2 dimensions. Maybe هذا Vx I plus Fy in 2 dimensions. I have a force J hat. Okay, what does it mean scalar? It means it can be positive, 0, or negative. Is 0 greater than a negative? It's scalar, and the positive greater than 0. The scalar quantity. It doesn't have dimension. Fx نفسها. Fy is also a scalar quantity. Okay, so this is important that it's good that you asked me this question because we need to clarify it. Yes, so the same thing with of course, we will do the same thing with acceleration. A velocity vector does not extend from one point to another, only shows direction and magnitude. طيب, let's see now what we will do with acceleration. The same thing. شوف انت today you're not learning a new science. Today you're just expanding or generalizing what you learned in chapter 2. شوف كيف البداية الصح تكون صح. Question Faisal, he said, you said that I can get speed by, can I get instantaneous velocity by, yeah. Well, يعني إذا فهمت سؤالك, if you have instantaneous velocity, take magnitude instantaneous speed. أنت تقول لي مش العكس. لا, difficult. If I tell you instantaneous speed, you have no information about direction. You cannot find instantaneous velocity. يعني it doesn't go both ways. أنت بالسيارة when you drive in the car, الأودوميتر will give you what? الأودوميتر العداد السيارة will give you what? Instantaneous speed, but it cannot give you any information about which direction are you going in. You have to look around. You have to look at the sun and find your position with the global positioning system. Okay? طيب, good. So with average acceleration, I'll do the same. Before average acceleration was delta V over delta T, same thing. Average acceleration is V2 minus V1, means V final 2, V final minus V initial over delta T. And the same way with instantaneous acceleration, لحظة, instantaneous, it's the second derivative of position or the first derivative of the velocity. So in case of instantaneous velocity acceleration, هذا الانستانتينيوس is equal what? Vx I hat, Vy j hat, Vz cat, هذا اللي what? This is V instantaneous vector, right? If I derive each component, what is this? dvx by dt. This is ax, طبعا instantaneous. And if I derive this, what is this? ay, طبعا instantaneous also. And what is this? az. So I might have acceleration along x, along y, along z. طب الآن خلينا نربط حاجة مهمة. تتذكر قاعدة constant acceleration? We said in chapter 2, if I find for a certain motion that the acceleration is constant, I can use equations of motion. طب say that a particle along x has constant acceleration. Along y has variable acceleration. I can only use equations of motion along x. I cannot use equations of motion along y. Okay? ليه؟ لأنه one rule of equations of motion is that the acceleration has to be constant. Has to be constant. So in the projectile motion, if I have constant acceleration along certain dimension, then I can use what? I can use equations of motion along the constant acceleration dimension only. Okay. Right. So from here, الآن acceleration instantaneous is defined as what? A instantaneous, ax I hat, ay j hat, az k hat. And this is similar to, nothing is new, just need from you focusing. dvz by dt is easy. To get the components of acceleration, we differentiate the components of velocity with respect to time, nothing new. We differentiate the components of the velocity with respect to what? To time. What about the angles between the vectors? Yeah, the angles between the vectors will give me direction. When you define a vector and you give him a certain angle, you give it direction already. Relative to هذا positive x, خلاص, you give him direction. If I have components of a velocity and I have, of course, I can analyze this as x and y, the complete information. I know the magnitude, I know the directions, but I know the components. Okay? طيب. Let's move forward. Let's take this checkpoint together. We'll solve it together. It's good if you have a white piece of paper next to you where you can solve while you are taking the class. It'll make it more interactive. Let's read the question. It said, here are 4 descriptions of the position in meters of a buck as it moves in the XY plane. What is a buck? A buck is a disc used in hockey. You know, this famous sport in Canada and Finland and Russia and those cold countries. They play hockey on the ice. The buck is a black disc that is only sliding in 2 dimensions, doesn't fly. It keeps on the ground. They keep it all the time on the ground. Like football. Football is a 3-dimensional game because once you kick the ball in the football, you project it and then it can go in any dimension. The buck only can move on the ground. It can slide on the ice, so it has only 2 dimensions. Here are 4 descriptions of the position in meters of a buck as it moves in the XY plane. XY plane, XY, means along this plane, means it only 2 dimensions. طيب, الdimension along الX, the first motion, أعطاك الposition along الX, I gave you the position along the Y. In the second motion, he gave you position along the X, position along the Y, and so on. Here, by the way, he gave you the X and Y. What is this? هذا الX. صح؟ وهذا what? All this what? الY. Here, هذا all of it, لأنه all of it next to I hat. All of it X. وهذا الثلاثة هذا Y. Now it's clear, huh? Now it is clear. Yes, hockey. Yes, hockey game. Yes. طيب. Now, are the X and Y acceleration components constant? Is the acceleration a constant? He said, are the X and Y acceleration components constant? But I have position. But how to get acceleration if I have position? I derive how many times? 2 times. First derivative, take me to velocity. Second derivative, take me to acceleration. طيب, let's do it. يلا. أول واحد. Let's derive the first one. When you derive X, so what you get? Vx. What you get for Vx, اللي هو الأول واحد, number 1. What you get? Minus 3t square, derivative, minus 60 plus 40. What's the derivative for t? Is 4. Now, derive again للX. So it get what? Ax. When you derive it again, what you get? Minus 6. Aha, this is good. طبعا this is meter per second square. Always provide unit in physics. Minus 6, what does it mean? The acceleration along the X is constant. I can use equations of motion here. The acceleration along the X is ممتاز. Excellent participation. Excellent. Does not change. So the acceleration along the X is constant. I can use equation of motion only along the X. Okay? Only along the X. Excellent participation. MashaAllah. Excellent. طيب. Now take the Y. Derive the first time. What you get? 12t minus 4. Derive again 12. 12t. Derive again 12. So what does it mean? معناه ال AX وال AY are constant. Yes, so ال AX, yes, constant. ال AY constant. طب what will happen to the total acceleration then? ما هو كيف أنا how can I get total acceleration if I have ax and ay? A total magnitude is equal to what? Square root ax square plus ay square. Wallahi, if there is no t component, no t derivative, no t variable, I still get constant. Because انت عندك ارقام 6 و 12 square root 12 square plus 6 12, you get a number. So it does not depend on t. So x and y are independently constant. As a result, the total acceleration is also constant. Let's do number 2. Where is number 2? هذا number 2. Okay? Let's derive first time at x minus 9t square plus 4. Derive again minus 18t. Minus 18t. So ax has a t component. It's not constant. So x component of acceleration, you see the participation, mashallah, is variable. Excellent. Everybody should get it. Everybody. ما حدا يجلس مستمع. المستمع تروح عليه. ما حدا يجلس مستمع ومشاهد. Be active. طيب, good. So it is not constant. It's variable. I cannot use equation motion. خلاص. AY, شوف هنا AY, derive it the first time, minus 10t. Again, minus 10. Oh, AY is constant. So what happened to the total acceleration? واحدة تخرب خلاص. The total acceleration, one is not constant, means the total acceleration is variable. I cannot use equations of motion. Number 3. هذه number 3. Derive. يلا خلينا نطلع V first for number 3. What you get? 4t I hat, هذه مع بعض x وال y together, minus 4j hat. Now A, the 3, A is what? يلا ساعدوني. 4t is what? Is 4 minus 4 0. So this is 4 I hat meters per second. Is it constant or variable? It is, of course, what? It is constant. Ya salam. It is constant. Excellent. Excellent, 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 excellent. MashaAllah. Excellent. 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 Excellent participation. More than half of the class are participating. Number 4, let's do it together. هذه first one, a 12t square minus 2. Again, 24t. T? Oh, x, no. It's not constant. Y, yes. Why? لأنه derive the first time 0. Derive again another 0. So total overall for 4 is no. No constant acceleration. Okay, let me see participation. Can you repeat? Repeat number 4? I'll repeat number 4. No problem. Here is number 4. هذا الx وهذا الواي. طيب derive هذا 12 t square صح؟ ما خلاص constant. هذا once I derive 0 خلاص constant. Derivative of a 0 is another 0. So but how about x? X is not constant. Derive again تصير what? 24t. طب 24t is it constant? No, it has a t dependence. X is not constant. Well, is enough. واحدة تخرب over acceleration. Okay. Right. Good. Now, let's take this extended example. وركز معايا هذا المثال مهم لأنه يمتد over 3 pages. طيب, what is this? You have a rabbit, this golden rabbit, runs across a parking lot in the XY dimension. يعني على الأرض. What does it mean XY dimension? As example, this is X, this is Y. So the rabbit on the ground, it doesn't jump, it's moving on this plane على الأرض. So you have an X, or you have a Y. So he's moving in the fourth quadrant, which means البروجيكشن الاكس بوزيتيف لكن الواي is negative. So rabbit runs across a parking lot on which a set of coordinate axes strangely enough been drawn. The coordinates in meters means the position is in meter, x بالمتر والy meter as a function of second. And أعطاك equations by the way, أعطاك equations للx وأعطاك equation y. والله هذه very useful. If I derive the first time I can find the v instantaneous, vx طبعا و vy. I can get the v total with total magnitude was speed. Okay, and هذه can give me instantaneous velocity, not average velocity. He said at t equal 15 seconds, what is the rabbit's position vector? What does it mean? أعطاني position vector in general at any time لأنه it has t dependence. But he said at t equal 15 tell me the position vector. Simple. What should I do? يلا بالchat. What should I do? Tell me guys, what should I do? خلينا نشوف contribution. خلينا نشوف contribution. What should I do to solve? Yes, I substitute the 15 بالx و substitute the 15 في y, and this is my position x or y. So yes, x as a function. So what I do, he said, give me, I tell you the general equations for the position. Tell me at 15, where is the rabbit? So what should I do? This is the general equation of the position vector. R of t is x of t I hat, y of t j hat. Now, if I substitute at t equal 15, يعني أصب هنا 15, هنا 15, here is 15 seconds, here's 15, I can get R, x will y as a function at 15 seconds. So substitute هنا 15 square, 225 by 0.35, you get something, number, and it's negative. Then 7.2 multiplied by 15, لأنه هنا they need to substitute 15. So you get along x at 15, it was at 66. So the location along x was, شوف هنا projections, 66 meters at 15 seconds. هذا instantaneous position. Along y, substitute y, حط هنا 15, here is 15, and you get the number. When you substitute 15, you get minus 57. Even at 15 seconds, a rabbit was located at 66 meters على x coordinate, or 6 components, or minus 57 along y component. So I can write the position vector of the rabbit this way. 66 meters I had at 15 seconds. Not only seconds. At 15 seconds, J hat at 15 seconds also. But he might say, أنت عندك equation جميلة like this. If you put it in an Excel sheet or a Python or any computational tool, and you ask him, give me the location at any time. Yeah, how about at t equals 0? How about at t equals 0? t equals 0 معناها هذا 0, هذا 0. إذا what الx? 28. What t equals 0 هذا 0 وهذا 0. إذا what 30. شوف at t equals 0, where is it? 28 and 30. Yeah, so at t equals 0, the rabbit was here. The t equals 0, the rabbit was here. How about at t equals 5? What you do, you substitute 5. You get it, and it will be this x and this y. How about at t equal 10? Yeah, this x, this y. This is the one we solved, t equal 15. And how about 20? Then, doing this, you can project the trajectory of the rabbit. You can predict. This is why these equations are good. It can give me the trajectory of the motion of the rabbit with time. So by doing this, I managed to find from this trajectory where should be the rabbit be running at every time. So why I need this? Because in the next slide, he will ask me about the velocity. Then in the next slide, it's an example in the book, he'll ask me about acceleration. And by the way, what if he said, give me the magnitude of the position? خلاص, طبعا هذا back at 15 seconds. What's the magnitude? Square root, square. 66 square plus minus 57 square, 87. يعني what does it mean? هذا length at 15 seconds is what? 87 meters. هذا معنى البوزيشن. Relative to the origin, this is the position of the rabbit at t equal 15. Similarly, what if he said, what's the angle? يعني where the direction of the rabbit at 15 means which angle I look for. هذه الانجل. احنا قلنا clockwise should be negative. طب how to find it? Tan theta, opposite, بدون إشارات. Opposite, which is divided by adjacent, اللي هو 66. Opposite divided by adjacent, 41 should be negative. Or instead of you say 30 or 41, you can say, well, the rabbit is at 319. هذه الانجل كم؟ 300 counterclockwise 19 degrees لأنه 319 41 360. So 319. Okay. طيب هذا الفيرست example. Let's go to the second example. He said, now the rabbit, remember the rabbit, the position? Now we'll talk about velocity. For the rabbit in the preceding sample problem, the previous slide, what is the velocity at t equal 15? Oh, velocity at t equal 15, I need to derive again. It's not important. Sorry for this interruption. Fine. So now in the preceding example, you have the position. What is the velocity? What is the velocity? What to do with this velocity? What to do? How to find this velocity? I derive. So I have this position, x. If I derive it relative to t, I get what? Vx. Derive it. 0 minus 0.31 t squared. Derive it minus 0.62 plus 7.2. Good. Substitute at t equal 15. He said, give me minus 2.1 meter per second. معنى هذا الرابط اللي بthis trajectory, he was having an x component of minus 2.1 to the left. Yes, salam. Very nice. And he will have a y component, if you derive, or substitute 15, this. Substitute ال 15 تطلع minus. He has a y component. Tangent, هذا الفيكتور that I need to analyze. يعني I'm not surprised that I got y because at t equal 15 the rabbit was here. The tangent is this vector, so it has two components, x and y, and both of them, x to the left, well, y down. So it's not a surprise for me that I got the